today in this class we have to start from 20.4 topic, that is tree diagrams, right?
Yes.
Pure mathematics. Okay. In the previous two sections, you have met and used these results. Which results? When the outcomes or events are mutually exclusive, we use the formula probability of A or B, that is equals probability of A plus probability of B. And we have also studied that for independent events, we have the formula that probability of A and B is equals to probability of A multiplied by probability of B. Do you understand?
Yes.
Some problems required using both of these principles together. Tree diagram are one way of doing this. So in this topic we deal with the tree diagram, and tree diagram is very important when we solve problems involving probability. So here is the example that Ollie and Dora are playing a game of battleships. For each game, the probability that Ollie wins is 0.4 and the probability that Dora wins is 0.6. They play two games. Represent this information in a tree diagram. This is your first questions part. Work out the probability that Ollie wins both games. This is your second part. Work out the probability that Dora wins exactly one game, right? So first of all, we have to just make the tree diagram. How? Because as you can see that in the question he has given that Ollie wins probability is 0.4. Ollie wins probability is 0.4. It means that Dora wins probability is 0.6. That is also given in the question, right? Do you understand?
Yes.
Okay.
Yes.
Next, again for second game, Ollie wins probability is 0.4. The first set of branch shows the possible results of the games, and in the second game, Dora wins probability is also 0.6. In this case, you have also the second game, and in this second game, the Ollie wins probability has 0.4 and the Dora wins probability is 0.6. As you can see in the question, the probability that Ollie wins is 0.4 and the probability that Dora wins is 0. They play two games. That's why we use two steps in the tree diagram, right? While the second set shows that the possible results in the second game. Understand?
Yes.
Next is part B. We have to work out the probability that Ollie wins both games. So here in this case you can see that this is the probability of Ollie wins, that is 0.4, and in the second game Ollie wins probability is also 0.4. So they are independent events because one game is independent to other game, right? One game's outcomes does not affect the outcomes of second game, so that means its probability is A and B, right? Probability of A and B, that is equals probability of A multiply by probability of B. So probability of A is 0.4, probability of B is 0.4. So when we multiply these probabilities, your answer will be 0.16, right? This is the probability of Ollie wins both games. Understand or not?
Yes.
Okay, good. Next one is part C. We have to calculate the probability that Dora wins exactly one game. So it means that in this case, Dora wins one game in that branch of this tree diagram. And in this game, in also that branch, Dora wins only one game. So it means that we have two branches in which Dora wins only one game. In that branch, Dora lose first game and wins second game. In the second branch, you can see that Dora wins the first game but loses the second game. So its probability will be 0.4 multiplied by 0.6, that is 0.24. And also in that case we have the probability 0.6 multiplied by 0.4, that is also 0.24. Now we have to find the probability of exactly 1. It means that we have to add these probabilities. So 0.24 multiplied by 0.24, it will becomes 0.48. This is your probability of Dora wins exactly one game, and this is your solution of this example. Any problem?
No.
Okay, good. Next is the exercise 20.4. You have total 5 questions, and you have to do first 3 questions from this exercise after doing this previous example, right?
Okay.
So you have to do this example and send it to me quickly. Okay.